Alright, so in this video we're going to finish off the last few questions related to this. So we have f of x is given by this expression for x is an element of real numbers, and we are given this domain restriction. If the range of the function is this, find the value of a. So we are going to draw the graph of this function. So we have f of x is equal to x squared minus 2x minus 3, and x is restricted between negative a and positive a. So we need to figure out what a is. And f of x, the range of this function, is restricted from negative 4 to 5. 5 and negative 4. Alright, so let's complete the square. If I complete the square, I get x minus 1 squared, right? So that gives me x squared minus 2x plus 1, and then I need to subtract 4. So now I can draw the graph, or I can at least visualize the graph. So my vertex is going to be at 1, positive 1, comma, negative 4, right? So positive 1, so this tells me I need to shift 1 unit to the right and 4 units down. So this vertex is going to be at 1, comma, negative 4. And it's going to be concave up. So my graph's going to look something like this. So I don't know exactly. So if x is 0, then I have negative 3. So this is going to be negative 3. So let me draw it a bit more like this. Alright, so when x is equal to 0, then it's equal to negative 3. Something like this. So if it's 0, then you have negative 3 here. Alright. So now, if x is negative 4 is the lowest part, is the minimum point of this graph, right? So this value occurs at the minimum point. Now let's check when x is equal to 5, or when f of x is equal to 5. So we want to solve for f of x is equal to 5. So x minus 1 squared, which is f of x, right? Minus 4 has to be equal to 5. So x minus 1 squared has to be equal to 9. X minus 1 is equal to plus or minus 3, right? X minus 1 can be positive 3 squared, you get 9. Negative 3 squared, you get 9. So x is equal to 4, or x is equal to, let me see, is negative 2. Alright, so if I have, so negative 2 comma 5 is a point on my graph, and 4 comma 5 is a point on my graph, right? So now we want to consider this orange portion of the graph. So now I want to restrict the domain from negative a to positive a, and I need it to cover this range, right? So, because I need it to be symmetric, so negative something to positive something, now I need to check how can I figure out the restriction of the domain so that this range is satisfied. Now, if you think about it, right, I have negative 2 here. If I go until positive 2, if I put positive 2 here, I'm going to get 2 minus 1 is 1 squared, minus 4 is going to be negative 3. So positive 2 comma negative 3 is going to be somewhere here, right? So now let me check this red portion of the graph. So from the orange portion, let's check the red portion. So does it cover the required range? It does, right? Negative 4 to 5, everything is covered here. And can I find the symmetric restriction? Well, I can. Why? Because I can start at negative 2 for x, and I can end at positive 2. So therefore, your a value is going to be 2. So the easiest way, I think, to figure this out would be to just plot the graph and then try to figure out how you can get a symmetric domain restriction. So that is going to be your answer. So you just draw out the graph and you check which value of x is going to satisfy the given condition. All right. So let's move on to question 14. It's very similar again. So I have this curve. F of x is equal to x squared plus x minus 4. And the domain restriction is a, x, and a plus 3. And the range restriction is -2, f of x, 16. So find the possible values of a. If I complete the square again, I get x plus half squared. So this gives me x squared plus x plus 1 by 4. Right? I get plus 1 by 4. So I need to remove that 1 by 4, and I need to subtract 4 as well. So if you simplify this, I believe you get 17 by 4. I think you do. All right. So now I have this. I can draw the graph, right? So if you complete the square, you get that expression. And now I can draw the graph. So this tells me I need to shift half units to the left and then down by 17 by 4 units. So let's say our vertex is somewhere here. And it's going to be concave up. All right. So this point is at half, comma, negative 17 by 4. And it's concave up. All right. So now we have restricted, right? Our restriction is from -2 to positive 16. So let's solve for these values. So I have x plus 1 over 2 squared minus 17 by 4 is equal to -2. And that gives me x plus half squared. If I add, so -2 is just -8 by 4. So -8 by 4 plus 17 by 4 is 9 by 4, right? If you add, I believe you're going to get 9 by 4. So x plus half is going to be plus or minus 3 by 2 if you take the square root. And therefore, x is equal to 3 by 2 minus 1 by 2. X is equal to minus 3 by 2 minus 1 by 2. So that gives you 2 by 2 is 1. -3 by 2 minus 1 by 2 is -2. So now we know that if you want to go -2, then your x values are 1 and minus 2. So, sorry, this has to be minus half, right? Because we had plus here. All right. So we have x is 1 comma -2. And we have x is -2 comma -2. All right. And now we need to go up until 16. So we're going to solve this equation again until we get to 16. So 16 is just 64 by 4. So x plus half squared, you're going to get 81 by 4. I think, yeah. And x plus half is going to give plus or minus. If you take the square root, you're going to get 9 by 2. So x plus half is equal to 9 by 2, and x plus half is equal to -9 by 2. And if you subtract half from both sides, you get 8 by 2, which is 4, and you get -10 by 2, which is 5, -5. So you have 4 comma 16 and -5 comma 16. So these are your points, right? So now your domain restriction, you want to consider where your range is included. So my range is included on this side, or it's included here, right? That is the range restriction. Now we want to check the domain, whether our domain restriction satisfies the condition. So if a is -5, if I pick -5 to be my a, and -5 plus 3 is going to be -2, right? So -5 is a valid pick. And again, if you pick a is equal to 1, 1 plus 3 is going to give you 4. So a is equal to -5 and a is equal to 4, a is equal to 1, both will satisfy. So these are both possible solutions. So you just want to draw the graph and check whether the domain restriction you can find from the graph satisfies the given condition. So a is -5 and a is equal to 1. So that is going to be your solution for 14. Moving on to question 15. We are given f of x is equal to this expression. So the first part asks us to complete the square. And then it's a state the value of k for which the graph y is equal to f of x has a line of symmetry. All right. So f of x is equal to 2x squared minus 8x plus 5. X is a real number. And you have this domain restriction. All right. So now let's factor out the 2 first. Right? I have x squared minus 4x plus 5 over 2. And now I can complete the square inside. So x minus 2 squared will give me x squared minus 4x plus 4. So I have plus 4. I want to take away that 4, and I want to add my 5 by 2 back. There is no plus 4 here. This square term will give us a plus 4, so we need to take that away, and we need to add our 5 by 2. So x minus 2 squared, that is minus 8 by 2, that is minus 3 by 2, I believe. And if you finish, you get 2x minus 2 squared minus 3. So that is your solution to part A. Now we want to visualize the graph. So the 2 in front of the square term, that just gives us a stretch, so we don't really care about it. So x minus 2 means shift the vertex point 2 units to the right and 3 units down. So here. And then it's going to be concave up because 2 is positive. So our graph may look something like this. So we don't really care about the values. We just want to visualize the graph, right? So now, we are restricting our x starting from 0. So if I put 0 here, I get minus 2 squared. If I put 0 into this equation, right? I get minus 2 squared is 4, 4 to the 8, minus 3 is positive 5. All right, so my graph is very inaccurate here. Okay, so the graph should look something like this. So let me draw my point. So my vertex point, let's say it's somewhere here. It's at 2, negative 3. And now I need to draw my parabola like this. And then it intersects my y-axis. When x is equal to 0, I get 5. 0, 5. All right, so I have this expression. So my graph looks something like this. So now it says I need to restrict y is equal to f of x so that it has a line of symmetry. Well, the line of symmetry has to pass through the vertex, right? That is the point where your graph can be symmetric. So if you flip this part, so we have starting from 0, we want to go to the vertex. So now you're going to flip it over this vertical line. This is the line of symmetry, right? So if you flip it, you're going to get something like this. So you just want to find out what point this is. So you start at 0, you have gotten 2 units to the right, right? So you just want to go the same number of units to the left. Sorry, you just want to move 2 more units to the right. So you're going to get 4, 5. And you can try. You can plug in 4 here. That gives you 5 again. So if you have 4, 5, if you restrict it this way, you're going to see that you're going to get a symmetrical graph. So from 0, if you want to go to the vertex, you need to move 2 units to the right. So you need to move the same number of units to the right again to get to your other point that's going to give you the same output as you had when you had 5. So you go to 4. So your upper restriction, the value of k, must be 4. All right. For your value of k from part B, find the range of f. So your minimum point was negative 3. F of x, and then when you went to k, you got up until 5. So from negative 3 to 5 is going to be your range. And yeah, negative 3 up until positive 5, where x is real and k is equal to 4 is your solution. And 2x minus 2 squared minus 3 was what our graph looked like. All right. So we are done with question 15. So now find the largest question 16 is very important. Find the largest possible domain for each function and state the corresponding range. So this is a linear function. You can draw it out. It's going to look something like this, right? So for a, x, your domain can be any real number. You put in any real number, you're going to get an output, right? So negative infinity to infinity. And your range is also going to be any real number. Negative infinity to infinity. So that is the solution for A. That works for a linear function. Now part 2 is a quadratic function, right? You can draw the graph. You can visualize the graph. So your vertex is y is equal to x squared. You draw it something like this, and this tells you to shift it 2 units up. So your graph looks something like this. So your vertex is at 0, 2. So your range, so your domain is that your x can be any real value. You're going to get an output. But your range is going to be a real value, but your range is always going to be bigger than or equal to 2. Your minimum point is 0, 2. So your output is always going to be bigger than or equal to 2. So this is your domain, and this is your range. All right. Question 3. So 2 to the power x, and we've done this before, right? It looks something like this. So your domain, again, is all real values. You can put any x inside and you're going to get an output. But your range, your set of output values, your f of x is always going to be bigger than 0. It's asymptotic here. It's never gonna, it approaches 0, x goes to negative infinity, but it's never exactly gonna be 0. So that is your solution to C. For D, we have discussed this function as well. F of x is equal to 1 over x. So let's visualize the graph. The graph looks something like this. So your domain is that x is an element of real numbers, but do we consider all real numbers? No. X cannot be equal to 0. X cannot be equal to 0 because it's not defined when x is equal to 0. If x goes to 0 from the positive side, so if x goes to 0 from this direction, it goes to positive infinity. If x goes to 0 from the negative direction, then it goes to negative infinity. Now let's talk about the range of this function. F of x is also, it almost covers all real numbers, but your output can also never be equal to 0. And that is obvious, right? It's asymptotic here. It approaches 0 as x tends to infinity, positive infinity, or negative infinity, but it's never exactly 0. So your range output can never be 0 for this hyperbolic function. And I forgot the technical name. I think it's a rectangular hyperbola. So it can never be equal to 0. E. E is very similar. You have f of x is equal to 1 over x minus 2. Remember, x minus 2. So you're taking the graph of 1 over x. So let me draw the graph of 1 over x, right? 1 over x looks something like this. And you're shifting this graph 2 units to the right. We're following the same logic. You're shifting this graph 2 units to the right. So let's say, so we had this undefined behavior at 0, right? X is equal to 0. So that is going to shift 2 units to the right. So you're going to have undefined behavior when x is equal to 2. So your graph looks something like this. Something like this. So your domain is going to be x's real number, but instead of 0, now x cannot be 2. And another way to think about it is your denominator can never be 2 when you have a fraction, right? So if you put positive 2 here, you're going to get, your denominator can never be 0 if you have a fraction. So you put positive 2 here, you're going to get 0. So that is not possible. And your range, again, is going to be all real values, but your output cannot be 0. And you can visualize this. Your output cannot be 0. And in the domain, you cannot have positive 2. All right. And finally, so I hope I can erase everything here. We have f of x is equal to square root of x minus 3 minus 2. So the graph of square root of x, right? So the graph of square root of x looks something like this. And this tells us, x minus 3 tells us to shift this graph 3 units to the right. So now we have something like this. And then minus 2 tells us to shift it 2 units down. So now our graph is going to look something like this, as illustrated by the red line, right? So now this is going to be my minimum point. So my output, f of x, is always going to be bigger than or equal to negative 2, because we shifted negative 2 units down, and it's not going to go below this. So my output is always going to be bigger than or equal to negative 2. F of x is a real number. And another way to figure this out is that the square root of function, so whatever you have inside, doesn't matter. It's always going to be bigger than or equal to 0, right? So if this part is bigger than or equal to 0, then f of x is bigger than or equal to 0 minus 2, right? The minimum value this can take is 0. So the minimum value f of x can take is 0 minus 2. So f of x is equal to greater than or equal to negative 2. And x is a real number. And now the domain, right? So you can't put x less than 3. Why? Because think about it. If you have x minus 3 here, we already discussed that whatever you have inside your square root cannot be less than, it has to be bigger than or equal to 0, right? You cannot put a negative number inside your square root. So x has to be bigger than or equal to 3. X is a real number. So this is your domain, and this is your range. And we are done with all the questions from this topic. So I hope this was helpful.